Welcome to the ultimate Solidity Smart Contract Web3 Blockchain Developer course, Foundry Edition. Previously, we've done 2 other massive courses and tutorials like this, one of them with JavaScript and one of them with Python, and then now one in pure Solidity. And combined, those 2 videos have over 5 million views, making them the most watched blockchain developer educational material on the planet. And we're looking to do it all over again. We've learned a ton from making those first 2 courses, and we've taken all of those learnings from those 2 courses, wrapped them up into this one to make this one the best one yet. If you're more interested in full stack development and working with JavaScript, the Hard Hat one is still a phenomenal resource for you to get started. However, this one has a ton of advancements in it, making it the most cutting edge Web3 developer course, period. Having done one of these videos every year for the past 3 years, I've been reached out to by countless developers who are now full-time developers in the Web3 space, making a living, doing well, and contributing to Web3. And there are thousands that I have not met who have left comments or left me notes, and I know we're gonna do it again with this video. If you're looking to become a Web3, Solidity, smart contract, or blockchain developer, or any of those terms, this is the course for you. And this course is for anybody and everybody, no matter your blockchain or developer experience level. And additionally, we're going to be using artificial intelligence to accelerate our learning progress. And I'm going to teach you not only how to become a blockchain developer, but how to work with AI tools to make you a 10x developer. If you have a little bit of developer experience before this course will be even easier to get through. But again, don't worry if you've never coded before. And for those of you who are already familiar with blockchain and smart contract development, feel free to jump around the different modules and different sections and grab the learnings that you want. I promise there's a lot of cutting edge information in here, and maybe you need to brush up. So no matter if you're brand new to coding, brand new to blockchain, or you're an experienced smart contract engineer, you're in the right place. Welcome to the edge of the rabbit hole. Let's get froggy. For those of you who don't know me, my name is Patrick Collins. I'm a smart contract engineer, security researcher, and just lover of all things Web3. I'm one of the co-founders of the smart contract auditing firm, Cyphren, avid smart contract YouTuber, co-creator of Web3Education.dev, and I live and breathe smart contract development. I absolutely love Web3, blockchain, and smart contracts, and I love the power and the tools that they enable us to use. But not only that, I love taking blockchain developers like yourself watching this video right now on the journey to becoming a successful smart contract developer. I think the key to Web3, to blockchain, to cryptocurrencies being successful is having a phenomenal foundation of developers. So I'm incredibly excited that you're here with me. And for those of you who don't want to become blockchain developers, the first 2 lessons of this course, lesson 0 and lesson 1, are foundational pieces of conceptual information for you just to understand how to get into this Web3 thing. So if you don't want to become a developer, just stop once we get to the coding. For my Pythonistas here, I'm working on an edition of this course purely in Python and Viper. Stay tuned for that as well. In any case, I'm incredibly excited for your journey. This is a data dump passion project of all the knowledge that I've collected over the past few years of working in this industry and being a smart contract developer myself. And at this point, I have the track record to show that I am 100% confident that if you follow along, if you code along with us, if you follow me on this journey, you will come out the other side armed with the knowledge to be a positive force for the cryptocurrency and blockchain industry. Smart contract and Solidity developers are massively in demand, with an average salary being around $145,000 a year. And with AI coming in place, it's becoming even easier to get up to speed quickly. But only those that understand the technology truly will be able to take advantage of all these advancements. AIs get stuff wrong a lot. So we especially need the knowledge to fact check whenever AIs get things wrong. Being here, you have the opportunity to be a pioneer, ushering in the age of Web3, of cryptocurrency, blazing the trail of where this phenomenal industry has yet to go. Like I said, this isn't the first time we've done this. We've already helped so many developers get into space, and we're gonna give you the cutting edge, most modern tools for industries like DeFi, NFTs, DAOs, tokens, upgradable smart contracts, blockchains, and everything else that you can think of. Once you finish this course, it will be abundantly clear what you want your next steps to be. And you'll have a ton of economic opportunity at your fingertips and opportunities to make a huge difference in this amazing industry. However, I can't just give it to you. You have to come with me on this journey. You have to take the step. Despite what you might think you know, cryptocurrencies and smart contracts enable a more accountable world, a more transparent world, a more collaborative world, a world where promises can't be broken. And that's a world that I want to live in. We'll learn more about the purpose of smart contracts and the purpose of blockchain technology in lesson 1 of this course. And then, of course, we'll teach you how to build it. So before we even get started, I want to give you a huge thank you for even being here on this video and listening and being interested in engaging in this phenomenal technology. So thank you for being here and welcome to the rabbit hole, because we're about to drop down. With that being said, let's get froggy. So let's begin our journey by talking about some best practices. That way you can get the absolute most out of this course and be as effective as possible. Now, there are 2 links in the description that I want you to pause the video right now, go into the description and click on and open up. The first one is web3education.dev, and the second one is a GitHub link to a repo, also known as a repository, with all the code and all the lessons and everything we're going to be covering in this video. The web3education.dev site is an education site that we're working on to have all of this video and everything else and all the cutting edge learnings of blockchain developers in this course, in this site. So if you enjoy written context as well, be sure to subscribe to sign up for that so that you can be one of the first people to know when it launches. And the second site is this GitHub link. This is going to be your Bible for the duration of watching this video. It has everything that we're going to go over. It has all the code, context, text, etc. that you're going to need to be successful in this video. And I'm going to be referring to it pretty often as we go through the course. Additionally, in this GitHub, there's a discussions tab right here that you can click on. And in here is where you can ask questions, discuss with other people taking the course, interact with members helping out, and it's where you can discuss anything that you're having trouble with. And an important note, sometimes you'll see this as the ChainExcel.org Foundry Full Course. We recently renamed it to the Cypherin Foundry Full Course. So this is the correct link, but if you see ChainExcel.org, that's fine as well. That being said, as we go through this course, we're also going to teach you some best practices on working with artificial intelligence, how to best prompt these AI so that they can give you the best results. Just keep in mind, they sometimes get things wrong. And it's a good idea if you are going to use an AI to fact check it with a human or another resource. So be sure to say hi in the discussions and maybe meet some like-minded peers. And additionally, once we do get to the coding portion of this course, it's a good idea to code along with me as I'm explaining things. So having the video up as well as your coding screen is a good idea so you can follow along with me as I'm explaining it. Now, this space moves incredibly quickly. So whenever I open some documentation or some code base or something, I highly recommend that you open it as well in your browser, just so that you can know immediately right away that the code that I'm working with in the video is going to be the same that the code that you're working with locally. Now, we're going to be keeping all of the code in here up to date, but sometimes things change, and something that I do in the video might not be the most up-to-date best practice. So we're going to have this file called chronologicalupdates.md, where you can go in and check to make sure that you're working on the most up-to-date edition. So if you go into that file, each lesson will have a section, and if there's some update that we made to the lesson, you can find it in there. Additionally, if you think you found something that is different or doesn't quite work, be sure to make a discussion for it in that GitHub repo. Like I said, it's going to be your Bible. But yes, if you run into an issue, make sure that file is one of the first places that you check, just to make sure that all the code that you're working with is the most up to date. All of this is to say, if you run into an issue, jump to that GitHub repo and make a discussion. We will also be giving you some tips very soon about how to best make a discussion. Yes, asking questions to other human beings is a skill. And we're going to try to teach you to be the most effective, because asking well-formatted questions is not only the secret to being a fantastic AI prompt engineer, but also becoming an incredibly successful developer. We're going to learn how to ask well-formatted questions. And whenever we post on discussions or forums or whatever, we're going to work on formatting them as best as possible. Take breaks. I cannot tell you how many people have tried to rush through these courses and be like, oh, I'm going to finish in a single weekend. Your brain doesn't work like that. Your brain needs time to absorb the information. So take breaks. Maybe every 25 minutes to a half hour, take a 5-minute break. Or maybe you like working in longer chunks. Maybe take a whole hour and then take a 15-20-minute break. Don't try to rush through the whole video in a day. You're not going to retain the information. Go outside, go for a walk, grab some ice cream, get some coffee, go to the gym. Your brain needs time to have the information settle. Maybe every 2 hours, just step away, maybe be done for the day. Work at whatever pace makes sense for you. Everyone's going to have a different learning pace. There is no right speed for this course. I've had people take my courses in 2 weeks, in 3 months, in 6 months. It doesn't matter. Pick a pace that you can do and stick to it. Not only work at your pace, make sure that I'm talking at a pace that makes sense for you. There's a little gear icon in the YouTube video here where you can change the speed of how I'm talking and how fast the video is going. So if I'm talking way too fast for you, then you can slow me down. But if I'm talking too slow, then you can speed me up. So make the adjustments you need to make me go the speed you want me to go. Now, a giant video like this can be kind of hard to triage where you left off. So using the GitHub repo with the timestamps in there is a good way to say, okay, I was on lesson 1. Let's click the link there to jump right to the timestamp. If you pause a video in YouTube, you can actually right click and say, copy at current time, and maybe drop that into a notes folder somewhere so that you can always just pick right back up where you left off. Or like I said, you can use some of the timestamps in the GitHub repo associated with this course. Or depending on when you watch this, the web3education.dev site might also be up. Be sure to check that out as well. And of course, this course is modular, so you can bounce around topic to topic and go to where you want to go. If you don't want to do any full stack stuff, then skip that section. If you want to go right to the advanced stuff, do that. Like I said, go the pace and take the learnings that you want to do. And after every lesson, it might be a good idea to go back and reflect on each lesson to really make sure the knowledge gets ingrained. Repetition is the mother of skill, and we're going to be repeating a lot of smart contract development. Now, additionally, at the end of every lesson, you'll see a little QR code that looks something like this. And there will be a link in the GitHub repo pointing to the same place that this QR code is pointing to. These are optional challenges that you can do to try to make sure that you actually learned what was meant to be learned here. And if you do solve them, you get a very cool NFT along with it. Don't know what an NFT is? Don't worry, we'll teach you later. Blockchain development and open source development world is incredibly collaborative. So be sure to use tools like, of course, the GitHub Discussions tab, Ethereum Stack Exchange, the decentralized Q&A forum, Piranha, issues on different GitHubs, artificial intelligence, and more. And like I said, we'll give you more tips on how to most effectively use these sites in the future. And the reason I'm putting so much emphasis on this, and that I will continue to put so much emphasis on this, is being a successful smart contract developer is more than just knowing how Solidity works. Knowing where to go for information and how to collaborate with people is often more important than your smart contract knowledge, because oftentimes you're going to run into issues you don't know how to solve. So we're going to teach you to unblock yourself on this and really anything in life. Plus, syncing with other people in the space makes it way more fun. Now, before we can actually get to coding, we need to understand how the blockchain even works, what the purpose of these smart contracts even are. And this is essential to becoming a successful smart contract developer, because a technology is really just a solution, and a solution is only as good as the problem is. So we need to make sure we understand the problem really well so we know how to attack it with this smart contract technology. And the better you understand the smart contract technology, the better you'll be able to architect your smart contracts in the future and make really intelligent, really powerful systems that further this amazing industry. But if you already know the basics of blockchain, feel free to jump into lesson 2 and skip over lesson 1. So those are some of the best practices to be really successful with this course. But with that knowledge, you're now standing at the edge of the rabbit hole. And if you're like me, once you jump in, you'll just want to keep going deeper and deeper. I'm so excited for you to embark on this journey with us. And I'm looking forward to seeing you on the other side, just like the thousands of other developers who have taken these courses and have emerged the other side triumphant. So it all starts with blockchain basics. Let's get froggy. Now, since you're here, you've probably heard of Bitcoin before. Bitcoin was one of the first protocols to use this revolutionary technology called blockchain. The Bitcoin white paper was created by the pseudo-anonymous Satoshi Nakamoto, and it outlined how Bitcoin could make peer-to-peer transactions in a decentralized network. This network was powered by cryptography and decentrality, and it allowed people to engage in censorship-resistant finance in a decentralized manner. Due to its features, which we'll talk about in a little bit, people took to this as a superior digital store of value, a better store of value over something like gold, for example. And that's why you'll also hear people commonly refer to it as a digital gold. Similar to gold, there's a scarce amount or a set amount of Bitcoin available on the planet. only so much that you can buy and sell. You can read more about the original vision in the white paper. We have a link to the white paper in the GitHub repo associated with this course. Now, this was an insane breakthrough. And in a little bit, we're going to learn exactly how this is all possible and how this actually works under the hood. Some people, though, saw this technology and wanted to take it a little bit farther and do even more with this blockchain technology. And a few years later, a man named Vitalik Buterin released a white paper for a new protocol named Ethereum, which used this same blockchain infrastructure with an additional feature. And in 2015, him and a number of other co-founders released the project Ethereum, where people could not only make decentralized transactions, but decentralized agreements, decentralized organizations, and all these other ways to interact with each other without a centralized intermediary or centralized governing force. Basically, their idea was to take this thing that made Bitcoin so great and add decentralized agreements to it, or smart contracts. And in fact, technically, these smart contracts weren't even really a new idea. Back in 1994, a man named Nick Szabo had actually originally come up with the idea. Smart contracts are a set of instructions executed in a decentralized autonomous way without the need for a third party or centralized body to run them. And they come to life on these blockchains or these smart contract platforms like Ethereum. And it's these smart contracts that are going to be the core thing that we're going to be working on in this course and that we're going to be developing. You can think of smart contracts in the same way you think of traditional contracts or traditional agreements. They're just a set of instructions between parties. Except instead of written on pen and paper or typed up in Microsoft Word, they are written in code and embodied on these decentralized blockchain platforms. And that's also where they're executed, instead of being executed by the 2 parties or 3 parties or however many parties that are involved. This removes this centralized issue that we'll talk about more in a bit. This is one of the main differentiators between the Ethereum protocol and the Bitcoin protocol. It's these smart contracts. Now, technically, Bitcoin does have smart contracts, but they're intentionally Turing incomplete, which means they don't have all the functionality that a programming language would give them. This was an intentional move by Bitcoin developers. Bitcoin developers viewed Bitcoin as a store of value, versus Ethereum developers viewed Ethereum as both a store of value and a utility to facilitate these decentralized agreements. Now, these smart contracts on blockchains alone are absolutely incredible. However, they do come with a huge issue. If we want these digital agreements to replace the agreements in our everyday lives, they probably are going to need data from the real world. Blockchains by themselves actually can't interact with and can't read or listen to data from the real world. This is what's known as the Oracle problem. These blockchains are deterministic systems, and they're deterministic on purpose. And we'll learn more about how that works in the sessions to come. So everything that happens with them happens in their little world. But if they're going to be these agreements, they need external data and they need external computation. And this is where oracles come into play. Oracles are any device that delivers data to these decentralized blockchain or runs external computation. However, if we want our applications to stay truly decentralized, we can't work with a single oracle or a single data provider or a single source that's running these external computations. So we need a decentralized Oracle network similar to our decentralized blockchain network. Your on-chain logic will be decentralized, but you also need your off-chain data and computation to be decentralized. Combining this on-chain decentralized logic with this off-chain decentralized data and decentralized computation gives rise to something called hybrid smart contracts. And most of the biggest protocols that we interact with today are some type of hybrid smart contract, or interact with hybrid smart contracts to some extent. This is where the protocol Chainlink comes into play. It is a modular, decentralized Oracle network that can both bring external data and external computation into our smart contracts to make sure they're decentralized end-to-end while giving them the feature richness that we need for our agreements. Chainlink allows for us to get data, do upkeeps, get random numbers, or really customize our smart contracts in any meaningful way. Now, throughout the course, we're going to use the terminology smart contract. However, whenever we say smart contract, we're often using it a little interchangeably with hybrid smart contracts. But just know that when we say hybrid smart contract, we're talking specifically about smart contracts that have some type of off-chain component. Now, since Ethereum's release, a number of different blockchains or smart contract platforms have come to light, such as Avalanche, Polygon, Phantom, Harmony, and more. For the majority of this course, we're going to be assuming that we're going to be deploying to the Ethereum network. However, everything that we learn here is going to be applicable to the vast majority of the blockchains out there, like Polygon, Avalanche, Phantom, Harmony, etc. And understanding everything from Ethereum fundamentals will give you the skills that you need to switch chains very easily with literally one line of code. So don't worry about learning a specific tool or with a specific chain, because most of them work together seamlessly. Now, there are a couple of smart contract platforms that don't use Solidity, but still learning the fundamentals here will make you much better at those as well. And Ethereum by far has the most value locked and is the most used blockchain and smart contract platform out there. You'll also hear those two terms used a little bit interchangeably as well. Sometimes I'll say smart contract platform, sometimes I'll say blockchain. They kind of mean the same thing. Obviously, blockchains could mean store of value and smart contract platform, but you get the idea. Similarly, Chainlink is the most popular and powerful decentralized Oracle network, is the one that we're going to be focusing on for this course as well. Chainlink is also blockchain agnostic, so it'll work on Ethereum, Avalanche, Polygon, Solana, or really any other blockchain out there. Now, additionally, over the last year, a new term has come to light called an L2 or a layer 2. This solves an issue that most blockchains see where they don't scale very well, or they don't grow big very well. We'll be talking about L2s a little bit more in the future, but the basic concept of it is that blockchains can really only get so big. So what they do, if this is Ethereum, you can actually have blockchains hook into them to essentially make them bigger. If that doesn't really make too much sense, don't worry about it for right now. Layer 2s solve this scalability issues. And at the moment, there are two different types of true layer 2s, optimistic rollups and zero knowledge rollups. Optimistic rollups like Arbitrum and Optimism, or zero knowledge rollups like ZK Sync or Polygon ZK EVM. Yes, there's a Polygon chain, but there's also a Polygon ZK EVM L2. The two of them are very different. Don't worry about them for now. And in fact, it's this Arbitrum layer 2 where our challenge contracts are going to be deployed on this rollup. But like I said, once we learn how blockchains work from a basic level under the hood, then we'll explain more about how these L2s actually work. Now, throughout this course, you'll hear the term DApp, or decentralized protocol, or smart contract protocol, or decentralized application, and they all kind of mean the same thing. A decentralized application is usually the combination of many smart contracts. And when we get into Solidity, you'll see what a singular smart contract really looks like. And like I said, learning all these core fundamentals will make you a better Solidity and a better smart contract developer. You'll also hear the term Web3 a lot in this video and in the industry. Web3 is the idea that blockchains and smart contracts are the next iteration of the web. Web 1 being this permissionless open source world with static content. Web 2 being the permissioned web with dynamic content. But all the agreements and logic runs off of centralized servers where they control your information. And then Web 3 comes back to the permissionless web, but once again with dynamic content. And instead of centralized servers running your logic, decentralized networks run the logic, creating these censorship-resistant agreements that these smart contracts enable. It is also generally accompanied by the idea that the users own the protocols that they work with, and it's an ownership economy. You'll see what I mean later in this course. Now, we've talked a lot about the history and about the high level of these protocols and of these smart contracts and what they can do. But what do these smart contracts really mean? What is it when I say trust minimized agreements or unbreakable promises? What is the real value add of these smart contracts? Before we look under the hood and take a peek at how this all works from a technical standpoint, let's learn what all the value of this is. What is the purpose of us building all these technologies, of you taking this course? What problem does this technology solve? In my mind, a technology is really only as good as the problem that it solves. If it doesn't solve a problem, then why bother? Smart contracts, blockchain, Web3, cryptocurrencies, those are all just different words that encapsulate the idea of what we're doing in such a unique paradigm. I think the easiest way to sum up what these smart contracts do is that they create trust minimized agreements. And if you might be scratching your head to that, a much easier way to think about it is just they give rise to unbreakable promises. Yes, you heard that right. Unbreakable agreements and promises. Additionally, they give rise to speed, efficiency, and transparency, and a number of other things. I made a video pretty recently about exactly this. So let's dive in and take a listen to the purpose, the undeniable value of smart contracts. Cryptocurrencies fundamentally re-landscape markets and agreements as we know them. Unfortunately, you've probably only been bombarded with people screaming about NFTs and money. Now, some of the memes are fun, but let's forget the bullshit and get down to the essence of this space. If you're already in Web3, this is the video to send to your friends to explain why you're so excited about this space and explain why we're here. And then if you're not into crypto, you've come to the right place. And yes, there are fun memes and markets and there's some money stuff and there are all these things, but outside of all that, the purpose of blockchains relates to the age-old elementary school unbreakable promise, the pinky swear. Let's get froggy. Nearly everything you do in life is the result of an agreement or a contract. Your chair was the result of an agreement to buy and sell lumber, to assemble and sell the chair to a retailer on Amazon. Then you made an agreement to buy the chair for $40. The lights in your house are powered by electricity, which is an agreement from you and the electric company. You agree to pay them. In return, they'll keep the lights on. The electricity that they generate is agreements between them and engineers who built turbines to generate the electricity. With insurance, you agree to pay some amount of money to them every month, and in return, they will do nothing. They'll cover your medical bills. Almost everything you do and everything you interact with is the result of some form of agreement or contract in some aspect. Now, agreements and contracts can feel kind of abstract and boring to really grasp onto. So to simplify, we can also refer to them as promises. When you get an oil change, they're promising that they will faithfully change your oil in exchange for money. When you put money in the bank, they promise to keep it safe in exchange for them to use your money to give out loans. When you buy a lottery ticket, the lottery promises to give you a fair chance at winning a ton of money in exchange for you buying the ticket. Whenever you make one of these agreements, in a way, you're asking them to pinky swear to not screw you over and to treat you fairly. But this doesn't always happen. Let's look at a real world example of someone breaking the pinky swear. Back in the 80s and 90s, McDonald's ran a promotion for people to win money by collecting McDonald's Monopoly game cards. The idea was simple. You buy McDonald's, and in return, you get a chance to win $1 million. You can imagine McDonald's literally going, "Hey everybody, I promise if you buy our McFood and McNuggets, we'll give you a fair chance of winning this money. Woo!"
But they ended up breaking this promise.
Instead of having a fair chance of winning, your chance was in fact zero. In the mid-90s, between $13 and $24 million went into the pockets of not people playing the game honestly, but a group of corrupt insiders who had rigged the game. Meaning that when you played the McDonald's Monopoly game, you were buying into a set of lies and promises that were 100% always going to be broken. And the thing is, it doesn't really matter if this was McDonald's fault or not. They were the ones making the promises that they ultimately could not keep. Another way you could think about it is that that's $24 million that they essentially stole from you and I. Now, if this system was deployed on a blockchain with something called a smart contract, it would have been impossible to defraud this $24 million due to smart contracts being immutable, decentralized, and transparent. But I'll get back to that in a minute. In all the agreements and contracts we make, imagine making a pinky swear with a 10-year-old and imagining how that agreement would hold up. "Hey buddy, could you please keep my money safe? You can play with it if you like, but just please have it when I come back." Immediately, you might get that worrying feeling in your chest that something might go wrong, that this 10-year-old might lose your money. You might be thinking, how could I trust them? Will they break their promise? And this feeling of, I can't breathe because of untrustworthy situations happens to us all the time. Can I trust this used car salesperson to give me a good car? Can I trust this tag that says machine washable, or will it make my shirt shrink? Will my insurance provider break their promise of covering my medical bills when I get hit by a bus?
When Patrick promises he'll go on a hike with me, will he actually?
Yes, Becca, I actually will. The issue with our current agreements and contracts is we have to trust the people who are making them to do the right thing. However, often, they're actually incentivized to not do the right thing. Insurance doesn't want to pay out money. Sometimes salespeople just want to get the shit off their shelves. And with my girlfriend, I promised to go on a hike, but I hate hikes. Where else has this happened? Now you might be thinking, okay, Patrick, this seems cool, but like, where has this actually affected me? Well, the McDonald's lottery that we just spoke about above. During the Great Depression, with the run of the banks promised to keep our money safe, and that when we went back to go get it, they would actually have the money there. And well and behold, there were times that they didn't have the money there. Just last year, Robinhood painted this amazing picture. Come use our application. We will give you access to the markets. We promise we will give you, a retail investor, a fair chance of interacting with the world of finance. Psych. But not this asset, this asset, this asset, or this asset. The 2008 financial crisis. Remember that? Shady deals behind closed doors combined with lies about financial product brought the world to its economic knees.
How are you f***ing us?
Hyperinflation in Zimbabwe. Hyperinflation in Brazil. Theranos. History is a relentless lesson of trustworthy entities being notorious promise breakers. And we finally have a way to fix it with smart contracts. Now, before I jump into smart contracts, a lot of people might be thinking, hey, cool and all. However, we have systems in place to protect against a lot of these things, which is true and which is great. And that is a very helpful step forward. But these systems often break. The ones in 2008 definitely didn't work. The ones with the Robinhood crisis definitely didn't work. And even if these systems apply and you go to court to try to work them out, maybe you're in court for years before you actually see a resolution. And by that time, what you needed the money for is long gone. So what is this technology? What is this tool that can fix this fundamental problem in our agreements today? This tool is smart contracts, and this tool is what the blockchain was built for. Now, I'm going to give you a quick overview of what a smart contract is. However, I'm leaving some links in the description for more in-depth explanations. But the basics of them is a smart contract is an agreement, a contract, or a set of instructions deployed on a decentralized blockchain. And once the contract or set of instructions is deployed, it cannot be altered, it automatically executes, and everyone can see the terms of the agreement. The real basics of it is that the code is executed by a decentralized collective, like a group of people, but a group of people running a certain software. This means that no one person or entity can actually alter any of these agreements or change the terms of the arrangement. In these traditional agreements, whoever owns the contract, whoever owns the execution of the contract can flip a switch and say, we're not going to do that anymore. In smart contracts, in Web3, in blockchain, you no longer can do that. Typically, these smart contracts are on a decentralized blockchain and used in combination with a decentralized Oracle network to get the real world assets and information. And if these words sound like I'm conjuring up a magic spell, well, again, check the links in the description if you want to learn more about the technical implications. If you're not a technical person and you're not interested in getting to the nitty-gritty, you can kind of think of it like HTTPS. I bet the vast majority of you don't even know what HTTPS stands for, and yet you use it every single day whenever you log onto the internet. So how does this fix the McDonald's monopoly issue? In its traditional form, the lottery was executed behind closed doors. Somebody operated and owned the code and the contracts and the agreements that ran the lottery, and they had the power to alter it, and nobody other than the people internal on the lottery could audit this altering happening. Now, if the code for this lottery was deployed onto a blockchain, every time a hacker attempted to alter it, everyone would be notified. Not only that, but you couldn't even alter it because the terms of a smart contract cannot be altered once deployed. Combine that smart contract with a Chainlink VRF Oracle to get a verifiably random number, and presto, you now have a perfectly decentralized, unalterable agreement that is impossible to hack, commit fraud, or manipulate. We have just saved the public between $13 million and $24 million just by fixing the issue of trust. How does this fix Robinhood? Well, the problem with Robinhood is already fixed, right? Again, the problem is that there's a centralized body that can flip a switch at any time and say, yeah, you can't access these markets anymore. We're breaking our promise of actually giving you access to the markets. This is already fixed with something called decentralized exchanges, and these exist today. One of these exchanges is one called Uniswap. You can swap ERC20 tokens, which are kind of the equivalent of stocks, but some aren't, some are. It's a little confusing. I won't get into that here either. But it doesn't have that centralized body that can flip a switch and ruin access to the markets. And had these investors been on a decentralized exchange, it would have saved them hundreds of millions of dollars. And it would have prevented fraudulent market manipulation. How does it fix one of the banks? With transparency built in and automated solvency checks, you can build a bank-like smart contract that has insolvency checks built in that make it impossible to get there. Insolvent means broke as f***. Any agreement or any history lesson where there was a trust assumption that was broken, smart contracts can be applied to and should be applied to, especially in a time where big money runs, owns, and controls everything. We desperately need to move to a world where some self-interested centralized entity can't flip a switch and ruin people's access to the services that they need. We can move away from a world that is brand-based to a world that is math-based. Right now, if you interact with a service that you don't like or that they break their promise, the only thing you can do is walk down the street to the next service that's going to make the same set of promises, and you have to hope and pray that they're actually going to keep it. We can move from that to a world where we can just look at the math and say, oh, okay, 1 + 1 = 2. This is what this agreement is going to do for me every single time, guaranteed. Because it's a decentralized autonomous agent, has no incentive to be evil, and everything is transparent and out in the open. If I'm a big company, and if it was better for me for 1 + 1 to = 3, maybe I would go behind some closed doors and fudge some numbers and come back out and be like, hey, 1 + 1 = 3. But with smart contracts, that's impossible. Doing the right thing is infrastructural. Now, given the choice between two agreements, one where you have to trust a single centralized entity that they're going to do the right thing for you, versus a decentralized, untamperable collective, which one are you going to choose? I'm picking the one that can't screw me over every single time for every agreement I can apply it to. Now, this technology is relatively new, but we have already seen it re-landscape entire markets and continue to do so. The traditional financial world is already getting its lunch eaten by DeFi, or decentralized finance. There's already over $200 billion of people's money in these protocols to help have a more fair, more accountable, more transparent financial system. This DeFi movement is one of the main reasons I got into this space, because we desperately need to move away from where we are right now and end people's chances for wealth being sucked up by some group that's bending the rules in their favor. And smart contracts are our ticket to that better world. More and more industries are also coming over to smart contracts and blockchain because of all the innovations and because of all the advantages that it has. As we grow and as we get better, we get closer to this vision of having this concept fulfilled. Trust minimized agreements. These smart contracts are minimizing the trust that we need to give other people in order for these agreements to be executed. If trust minimized agreements is too confusing for you, just say unbreakable promises. Now, I gotta be honest with you guys. Blockchains and smart contracts and cryptocurrencies can actually do more than just trust minimized agreements. What? They have security benefits, uptime benefits, execution speed benefits, and a whole lot more. But it's a lot easier to just learn about one and learn the other ones later, right? It's kind of like sprinkles on top. So this is why we are here. This is why we're building this future. And this is why we are so excited about it.
Last year, 2022, there were a lot of issues with a couple different companies, like, for example, SBF's FTX platform. The thing to me that's most frustrating about that situation is that FTX platform wasn't anything that I just talked about. It wasn't decentralized. It wasn't trustless. It wasn't transparent. It was purely a traditional Web 2 company pretending to be Web 3 and just using the cryptocurrency part of Web 3, but not actually using the smart contracts. And we're doing a much better job as a community getting rid of the bad actors. And this is something that's incredibly important for you when working with protocols and when building protocols. I want you to be incredibly successful here, but I want you to be incredibly successful because you're making a ton of value. A lot of these platforms that we saw collapsing last year were not creating value. They were stealing value. They were siphoning value. They were faking having value. And as you learn and as you build smart contracts yourself, it'll start to become innately aware of what protocols and what companies are centralized and are not the ethos of Web3 and the ones that are. We are building verifiable, trust minimized agreements, unbreakable promises. And if you can't verify those promises, then it's not trust minimized. It's not Web3. It's not what this industry is for. That's what I want you to do as you finish this course, is be a force for good. Unfortunately, because a lot of people haven't taken my course, not everybody understands the difference between a legitimate project and a token that's just meant to pump somebody's bags. As this space continues to grow and as people like yourself take courses like this, we will get to continue to push real legitimate projects forward and wash out the projects that aren't actually contributing to Web3.
Whew. Even in just this introduction part, we've learned a ton. So let's do a quick summary of what we've learned so far. Bitcoin was the first protocol to take this blockchain technology into the limelight and take these cryptocurrencies into the mainstream. Bitcoin is a sort of digital gold, or a store of value, able to make transactions between users in a decentralized manner. Ethereum and other smart contract platforms take this blockchain technology one step further, enabling people to make smart contracts and decentralized trust minimized agreements. These smart contracts and decentralized applications can access and interact with the real world using something called decentralized Oracle networks. Chainlink is a decentralized network that allows us to build these hybrid smart contracts, which combines our on-chain logic with our off-chain decentralized data and decentralized computation, giving rise to our logic being completely decentralized and our data and external computation being completely decentralized,
giving us all the features that traditional agreements and traditional contracts have. Now, these digital currencies like Ethereum and Bitcoin have value even without the smart contract part. Having a censorship-resistant, decentralized store of value is immeasurably powerful in its own right. We have some links in the GitHub repository that'll teach you how this decentralized store of value flips traditional finance on its head. And it's another one of the great reasons for building smart contracts. But again, the easiest way to boil it down is trust minimized agreements or unbreakable promises. But let's also go into some of these other features that smart contracts have over our traditional environment. The first feature, of course, is that they are decentralized and they have no centralized intermediary. The different individuals that run one of these blockchains are known as node operators. And it's the combination of all these thousands of node operators running the same software, running these algorithms, running these smart contracts that make the network decentralized. We'll dive deeper into how that works later. The next feature is transparency and flexibility. In these decentralized networks, since all these individual node operators run this software, everybody can see everything that's happening on chain, meaning there's no shady deals, there's no weird things happening. Anything that's going to be unfair, people would be able to see and just not use. Everybody has perfect information and has to play by the same rules. Now, additionally, this doesn't mean that there's no privacy. The blockchain is pseudo-anonymous, meaning that you aren't necessarily tied to an identity in real life. They also have the feature of speed and efficiency. For those of you who have ever tried to do a bank transfer or send money across seas, you know it sometimes can take 2 to 3 weeks, when in fact, all these banks are really doing is basic math. They're subtracting money from your balance and adding it to some other balance. Why does it take so long? In the blockchain, all of these transactions happen instantly. Another instance for those in the financial world today know that clearinghouses and settlement days can take a long time. In the blockchain, there's no need for any of that because they happen instantly. This obviously is much quicker, but it also makes for much more efficient interactions with each other. Security and immutability. Again, immutable means that it can't be changed. Once a smart contract is deployed, that's it. Whatever's in the code is going to be in the code forever. They cannot be altered or tampered with in any way. This means that the security is much easier. Whereas in a centralized world, somebody can hack into the server, jump into the database, and change some numbers. You can't do that in the blockchain world. And since it's decentralized, in order to hack the blockchain, you'd have to take over half of the nodes, as opposed to in the centralized world, where you only have to take over one. In the regular world, if your computer and your backup computer go down, all of your data is gone. In the blockchain world, if your computer and your backup computer go down, all your data is safe because it's being run on all these other decentralized nodes. And even if a few hundred nodes or if a few thousand nodes go down, it doesn't matter because as long as one node has a copy of the blockchain, you're good to go. Hacking a blockchain is nearly impossible and leaps and bounds more difficult than hacking a centralized server. Not only that, but this is safer in the asset sense as well. All you need to access your credentials and your information and your assets is your private key, which is basically your password for all of this. And as we've discussed in the video, these smart contracts remove this counterparty risk, remove this centralized intermediary, remove these trust gateways that we have to do in Web 2. When we engage with users and individuals, they don't always have our best interests at heart. Smart contracts remove this counterparty risk because once one of these contracts is created, they can't go in and they can't alter it, and they can't let greed or ego or anything else get the better of them and alter the terms of the deal. And as we said, this gives rise to these trust minimized agreements or these programmatic unbreakable promises. We move away from brand-based agreements to math-based agreements, where we can look at the cryptography, we can look right at the code and see exactly what something is going to do and how it's going to execute, versus having to rely on a human being doing the right thing. With smart contracts and decentralized hybrid smart contracts, doing the right thing is infrastructural. All these pieces boil down to us having the freedom to interact the way we want to interact without having to be afraid that interacting like that is going to screw us over. This trust minimized piece, these unbreakable promises, make interactions so much better. In the purely Web 2 world, we're constantly bombarded with messages of projects and protocols pushing us to move or act in the direction that makes them more profitable. Versus in the smart contract space, we can see everything transparently and we can even engage and interact and be partially owners of the protocols and the interactions that we decide that we want to be a part of. So smart contracts have been around for a few years now, and what have they generated for? What industries have come about due to these smart contract platforms being around? Well, you've probably heard of some of these, and some of these we've already mentioned, but let's give you a quick refresher. DeFi. DeFi stands for decentralized finance, and it gives users the ability to engage with finance and markets without having to go through a centralized intermediary. For example, like we said with Robinhood, you no longer have to trust that Robinhood would continue to give you access to the markets. You instead would be able to see in the smart contract, yes, I have access to the markets. Or in the 2008 financial crisis, you never have to trust that these groups and institutions are giving you the correct things on the back end. You can see everything transparently right on the blockchain. You can engage with things like money markets and sophisticated financial products easy, effectively, and securely. If you're really excited about DeFi, we have a ton of DeFi examples showing you how to build and interact with these protocols in coming lessons. DAOs, or decentralized autonomous organizations, are another group that we've already mentioned. DAOs are groups that are governed completely decentralized by a set of instructions or smart contracts on chain. There are some massive benefits here where engagement's much easier, the rules are black and white, and you can see everything directly on chain. Voting and governance technology is completely decentralized. And the blockchain space is one of the big ones pushing how we can evolve politics and how we can evolve governance to make it more efficient, fair, and reasonable. And you better know it, we have some examples of how to build DAOs and how to work with DAOs in coming lessons. So be sure to watch those. NFTs stand for non-fungible tokens and can really be kind of described as digital art or just a unique asset. They can do so much more, but we'll keep it high level for now. Projects like Bored Apes and CryptoPunks have revolutionized the way that people get paid for their work, show off their creativity, status, and so much more. And yes, of course, we have lessons showing you how to create and interact with NFTs as well. So many other groups and so many other industries are being created as a result of this insane technology. And maybe after finishing the journey with us here, you go out and you'll be the one to pioneer the next industry or the next billion-dollar idea. You've learned so much already. But now that we've learned a lot of this high-level information, let's finally jump in and let's make your first transaction and let's get you set up to interact with this new world. In this next section, we're going to get you a wallet and we're going to show you exactly what a transaction looks like and feels like. Let's dive in.
This is the Ethereum website, ethereum.org. We are going to make a transaction on a test Ethereum blockchain. I'll explain what that means in a little bit. This is going to be our first ever transaction that's made on the blockchain. And this process of making a transaction is going to work the exact same across all EVM compatible blockchains and layer 2s, like Arbitrum, Ethereum, ZK Sync, and etc. I'll explain what EVM means in the future. For now, just follow along and have fun running your first transaction. Now, in order for us to send a transaction on any of these EVM chains, the first thing that we need to do is set up a wallet. So I'm going to go to MetaMask because it's one of the most popular wallets and one of the easiest wallets to use. I'm using the Brave browser, but it works for Chrome or Firefox or really any other popular browsers out there. And it's just going to be an extension in the top right hand of our browser. It's going to make it very easy to see anything to do with our wallets and our transactions very easily. And it's going to store all of our EVM-based currencies and EVM-based transactions. So I'm going to go ahead and hit Add to Brave, Add Extension, although Brave does also come jam-packed with its own wallet. So now we come to the Get Started page, and I'm going to go ahead and select Create a New Wallet. Sure, we'll agree to help out MetaMask. Now we're going to create our password, make sure it's really secure. For the purpose of this demo, mine's going to be kind of mediocre. Now I'm going to preface this. This wallet that you're making right now, as you follow along with me, this is going to be your development wallet. So if you want to make the password a little bit weak, just so that you can test things out very quickly, go for it. Just know we're never, ever going to put real money into this wallet. It's good if you treat this as if it is a real wallet. That way you'll get used to and you'll get familiar with good wallet safety. You'll then get a video like this, which will teach you about the secret recovery phrase, which we saw a little bit earlier when we were creating our wallet. Let's watch this video.
MetaMask is a new way to connect to sites and applications. On traditional websites, a central database or bank is responsible for controlling and recovering your accounts. But on MetaMask, all of the power belongs to the holder of a master key. Whoever holds the key controls the accounts. Your secret recovery phrase is your master key. It's a series of 12 words that are generated when you first set up MetaMask, which allow you to recover your wallet and funds if you ever lose access. It's important that you secure your wallet by keeping your secret recovery phrase very safe and very secret. If anyone gets access to it, they will have the master key to your wallet and can freely access and take all of your funds. To secure your MetaMask wallet, you'll want to safely save your secret recovery phrase. You can write it down, hide it somewhere, put it in a safe deposit box, or use a secure password manager. Some users even engrave their phrase onto a metal plate. Nobody, not even the team at MetaMask, can help you recover your wallet if you lose your secret recovery phrase. If you haven't written down your secret recovery phrase and stored it somewhere safe, do it now. We'll wait. And remember, never share your secret recovery phrase with anyone, not even us. If anyone ever asks you for it, they're trying to scam you. That's it. Now you know what a secret recovery phrase is and how to keep your wallet safe and secure.
Awesome. So that was a great introduction to keeping your wallet safe. We'll talk a little bit more about safety with our wallets in the future. Let's go ahead and select Secure My Wallet. Now, this is where we need to write down our secret recovery phrase and save it in a very secure place. It gives us some tips here, like a password manager, a safety deposit box, or split it up and keep it in multiple secret places. For the purposes of this video, I'm going to be showing you the secret recovery phrase because I'm not going to put any real money into this, but you should never ever do this. Additionally, you'll sometimes hear mnemonic as a synonym for secret recovery phrase. The main takeaway from all this is you should never share any of this. This is for you only. If you show this secret phrase to anybody else, they will have access to not just one account, but every account that you make in MetaMask. So be absolutely certain to not share this with anybody. So again, I know I'm belaboring the point a little bit, but everything that we're going to do in this tutorial, we're going to do with fake money and fake assets, and never put actual money into this account that we're making here. Once you get familiar with using MetaMask and working with the tools and staying secure, then you can go ahead and create a separate MetaMask that will have real funds in it. If you want to put real money in different MetaMask, a lot of browsers have a profile option, and maybe you can make a new profile, install MetaMask on that different profile, call that profile Real Money Profile or something, and that's where you will store your money. But for this video, for this tutorial, the MetaMask that you are using is going to be specifically for testing things out, and you will never store real money to it. I'm going to harp on that a lot more in this course. So even if you're coming here and you have a wallet, I highly recommend still making a brand new one for this tutorial, just in case you don't accidentally code something or do something autonomous and give away your funds. If this is your first wallet, then great. But again, when you're working with real money, if you lose access to the secret phrase, you will lose access to all your money. So be sure to write this down. Promise me that you won't use real money for this course. Great. I'm going to hit copy to clipboard for now, and we're going to go ahead and hit next. Now we need to confirm by adding our seed phrase back in. We can go ahead and hit confirm, and we now have created our wallet. Let's go ahead and select got it. Awesome. Now we can see the interface of our MetaMask full screen. And depending on your browser, what you can normally do is hit this little puzzle piece on your browser and select this pin button. So now we can pin our MetaMask into the top of our browser. And we can click it like so, and we can see it give a little drop down like this, and we can see the same information in this little drop down as there is on the full screen. Now, even if you lose access to that page, now that this is bookmarked in your browser, you can select your MetaMask, select these three dots, and hit Expand View to reach this tab. Now, additionally, what we can do in here is we can actually go up to our accounts, and we can actually create multiple accounts by hitting Create Account. And if you wanted to, you could give it a name here. I'm just going to leave it as default for account 2. And now we have 2 separate accounts. We have an account 0 with an address and an account 2 with an address as well. Both of these accounts actually share that same secret phrase. So anybody with access to the secret phrase can actually have access to both accounts. However, they have different private keys, and that's what makes them different. We'll talk a little bit more about that in the future. If somebody gets access to a private key, they'll get access to a single account. If they get access to the secret phrase, they'll get access to all the accounts that you make. Even, if you made a third one, they'd get access to this one as well. Now, if you look up in the top right of the screen here, you'll see this section that says Ethereum Mainnet. This is our networks tab. And if you click it, you can see all the different networks that our MetaMask has access to. Ethereum mainnet is the main network of Ethereum, and this is where real money is spent and used. For this course, we're not going to be working with Ethereum mainnet. We're instead going to be working with something called a testnet. For both engineers and non-engineers, we often need a place to test or simulate our transactions. And for the developers here, throughout this course, we are going to teach you another technique for testing out your transactions on a local network. And a local network is actually going to be the preferred way we do our testing and our simulations. However, it's still really important to see end-to-end what a real transaction looks like, and that's what a testnet will do for us. It simulates exactly what a mainnet or a live money network would look like. However, there's no real money at stake, and we don't actually have to spend any money. To see some of the testnets that come default with MetaMask, we can hit the show/hide button, which will bring us to the settings page of MetaMask. We can turn on show test networks. And if we scroll back up, now if we hit our networks tab, actually, let's go ahead, close out of settings. Now, if we hit this dropdown, we can see Gorilla Test Network, Sepolia Test Network, and Linea Gorilla Test Network. These networks are test networks that resemble Ethereum or Polygon or Linea or Arbitrum or Optimism or ZK Sync or any other EVM compatible chain that we want to work with. And again, we'll define EVM in the future. And we can actually switch the network that we're working on simply by clicking another network. So let's switch to Sepolia. We can see our network changed up here, and now we can see we have 0 Sepolia ETH. So on ETH mainnet, this new account has 0 Ethereum, and on the Sepolia test network, we also have 0 Sepolia ETH, which makes sense because this is a brand new wallet. And we haven't put any money into this brand new account yet, so of course we have 0. At the time of recording, Sepolia is one of the most popular test networks out there. So we're going to be working mainly with Sepolia throughout this course. However, testnets often change because, again, they're run out of the goodness of people's hearts, and sometimes people stop running them. You should absolutely have either the web3dev.education site up or the GitHub repository associated with this course. And an important note, sometimes you'll see this as the ChainExcel.org Foundry Full course. We recently renamed it to the Cyphren Foundry Full course. So this is the correct link, but if you see ChainExcel.org, that's fine as well. And you should scroll down to the recommended testnets section to make sure you're on the most up-to-date testnet. At the time of recording, like I said, we're working with Sepolia. Throughout this course, we are going to show you how to work with different testnets and different networks as well, because it's incredibly important to do so. The blockchain world is moving into a multi-chain world, and especially with the popularity of L2s, which help Ethereum scale, learning the differences between different chains and different L2s is incredibly important. Now, same as Ethereum, what we can do is we can actually go to Sepolia Etherscan. So we'll go to sepolia.etherscan.io, and we can grab our address from MetaMask by clicking and copying the address here, pasting it into the Sepolia Explorer, and same as Ethereum, we can see our account balance, we have 0 ETH, there are no transactions, no token transfers, nothing, because obviously it's a brand new wallet. Now I'm showing you this because pretty soon we're going to send our first ever blockchain transaction. If you've never sent a blockchain transaction before, we're going to do it on this testnet to give you some confidence as what a transaction actually looks like when you do move over to a mainnet. And I'm showing you this site now because you're going to see when we send a transaction, a lot of this information is going to get updated. Now, just remember, like I said earlier, a testnet is run out of the goodness of people's hearts, so please use the transactions sparingly. Once you send your first transaction here, try not to send too many more, as one is good enough for you to see what's going on anyways. And in order for us to simulate one of these transactions, we're going to go to a faucet for a testnet. Testnets have this thing called faucets, which allow us to get some free Sepolia ETH so that we can test out sending transactions and receiving transactions. If you go to the GitHub associated with this course or web3dev.education, we can scroll down to this testnet faucets section and select one of the links to go to one of these testnet faucets. Right now, the recommended faucet that we're working with is faucets.chain.link, but be sure to use the GitHub repo